Today we're looking for non-trivial solutions to this one equation and two unknowns, and they're rational solutions. Now, what I mean by a trivial solution is if you just set x equal to 0 in this equation, these two terms vanish right here. You get 73y is equal to 20,000. And so the y coordinate, which would just be the x-intercept of the y-intercept for whatever this graph looks like, would be 20,000 over 73, right? Okay. Now notice this is certainly a proud member of the rationals crossed with each other. This is a Cartesian product of rational numbers. It's how you write all possible ordered pairs of rational numbers. 0 is certainly a rational number, right? But anyway, we're not interested in the 0. So we're searching for coordinates, neither one of which is 0. Okay. Now, so let's go down and look at this approach I've adopted right here. This is a little bit of a crutch of mine right here, but what I did is I stole 1,000 from this side, and we're rooting for this thing to factor in some sort of nice way, okay? But in order for it to factor, the most so-called most complicated term has to be accounted for first. So let's look at it like this. And y'all, the goal is to get this to happen. Okay, get some binomial factors here. So this is equal to 10,000 still on this side. Okay. Now, we need to get this term to occur somehow or another. Okay. So there's more than one way to do it, of course, but you could do minus 73, let's say y. Now, if you're going to put minus 73y here, okay, you're going to have to put 73x on this side. And it may be a little more customary to put these out front, but those are just conventions. I like to keep them close together just so I can see what I'm doing, kind of. It makes just psychological baggage, I guess. But anyway, this times this is this, right? Now we need for the 730,000 to happen, right? But what is the only way for that to happen, right? If you want 730,000x to happen, what do you need? You need 10,000 in this position here. Again, folks, we've already gotten this term taken care of by putting these two guys in this position, right? But we also have this term 730,000. So we have to put the 10,000 factor right here to get this to happen. I mean, so this times this gives you that, right? Okay. Now what else? There's only one other possibility for the last position to get the minus 10,000. That would be a minus 1 right here, right? Okay. And again, notice how 73y is accounted for also. 73y would be minus 1 times this, right? Okay. So it all works out if you expand this out. And again, this is nothing but trial and error. There's no sophisticated scheme here. You just have to try it. If something hadn't worked out, you wouldn't be able to factor it in a nice way. Okay. And since we're looking for rational solutions, you sort of, if the problem composer is doing this right, it should break out like this some way in order to get rational solutions. Otherwise, there wouldn't be rational solutions. Okay. Now, so probably I don't know which it does. I don't know if it makes much difference, but you can write this as equals to 1 times 10,000. It's not the only factorization, of course. You know, there's many other divisors of 10,000. Okay, but let's see what happens right here. We'll try 1 in 10,000. All right, and again, we're just trying to find one rational solution. Of course, there would be many others depending on the factors, depending on this factorization over here. But if you equate this to 1, you get 10,000. Minus 73y equals to 1. Okay. Now, what does that give us here, folks? That's the same thing as 999 on this side. or 9,999. Okay, subtract 1, bring this over, divide by 73, and you get this. Okay, equals to y. Now, for the other one, we would have to set 73x minus 1. See, we set it equal to 1 over here. Now we have to set it equal to 10,000, the other factor. All right, and so we get x is equal to 1001 divided by 73. And y'all, it turns out that 10,001 is what they call semi-prime. It has a prime signature, I think, of 2-1 or something, however they do it, or 1-1, I guess. And but anyway, this is equal to 137. So 1001 is as close to prime. 10,001 is as close to prime as you can be because it's the product of, that's 137 right there. Okay, 137. So I guess this is the answer. This is certainly a rational number. You can think of it as 137 over 1. But maybe better is this the only integer one? I think all these others don't work out to integers. I'm not sure. I haven't checked them all. But you would have to check all the divisor pairs of 10,000 to determine that. But notice this just came out to be a natural number, okay, 137. And so your solution up here, let me see if I got this memorized here, 137. The solution would be, and again, a better question, I think, or a better set of directions would be to find a rational solution with a real, with just an integer coordinate, okay? So this was what, 999. 9 over 73, right? So again, the question's kind of boring the way I've worded it because, you know what I mean? I just said Q cross Q. A big question would be, is this the only natural number coordinates? And you would literally have to go through all of these factors of 10,000. And there's not as many as you might think. There's quite a few, but you could go through and determine if there's any other integer coordinates. But in any event, we have produced one rational solution. It said find non-trivial xy. Just one. Again, it's not the best question. You could say find all or count the number of non-trivials, whatever you wanted to do. But anyway, this is one, and this happens to be an integer, which might be something kind of special. I don't know if it's the only one. Okay, thanks for viewing.